Okay, so now let's see how the backup is possible for the distance relay. So in order to understand the backup protection of the distance relay, let us discuss. We have considered the four buses, that is the bus A, B, C, and D, and let us discuss the line is correct connected between bus A, B, B, C, and C, D. So three lines are connected in three line section. For each line section, so if I consider the line section one here, this is your first line section, this is your second line section, and this is your third line section. So in each line section 1, 2, 3, we have two relays R1 and R2. We have another two relays R3, R4, and R5 and R6 for each line section. So the first zone of the relay R1 that will reach up to 80% of the line section 1. So let us talk about the R1 only. So the distant relay has basically three zones, that is known as the zone of the distant relays. So the first zone of the relay R1 that covers 80% of the line from the bus A. So if I just draw 80% from the bus A, so this region, the first region of the distance relay R1. So it is indicated by the R1, that is relay R1, and the first zone, that is the first region. So if any fault occur in this region, then the relay will operate instantaneously. So without any time delay, relay operates instantaneously. Now, in the second zone, which is the time delay zone, second zone. So if I write here the second zone. Okay, so this is your second zone. That is your time delay zone. So the delay time, that is of the order of 0.3 to 0.6 second. So 300 to 600 milliseconds. So from this point, if any fault occurs in this region, let us say this is the 80% region. So this is 20% region here. Any point on this side, if any fault occurs in this 80% region here, so the distance relay sees this fault in second zone, and the distance relay will operate. After some time delay, so reach of the second zone delay, that will cover this remaining 20 seconds, and it will also extend towards the next section, adjoining section, that is the section 2 here. So it will cover up to 50%. So zone 2 will cover 20% of the first section, and so that is the first 50% of the adjoining section, that is second. So this is this zone 2 of the second zone of the distance relay, whereas the first zone, as I told you, the first zone that covers the 80% of the first line section. This is the one. So this is all about the second zone of the distance relay. Now, if I consider third zone of the distance relay, then the third zone. So in the third zone of the distance relay, the third zone that will act as uh, a backup relay. So if any failure occurs, then the distance relay will operate. If primary relay fails, that uh, distance relay, then third zone operates and provide a protection. So this indicates the delay in third zone. So delay third zone, that is roughly around 1.2 to 1.5 second. Okay, so if I just draw on the RX diagram, uh, the bus A, we have the line, and the bus B. So the first zone of the distance relay that covers 80% of the first line section. So this is our first line section. This angle is phi L. So if I just draw, let us consider the MHO Moho relay. So if I draw 80%, take 80% of the line section, then the distance relay characteristics that comes like this. So this covers the 80% of this line section. So now if we have another adjoining line section like this, so the second zone of the distance relay that covers the remaining 20% of the first zone plus 50% of the second zone, second line section. So it start again from here and uh, from here, and you can take 50% of this section. So this will cover this much region. So this is your basically you have the Z1 and you have the Z2, and this is the Z1 region which covers the 80%, and this is the Z2 region which covers the 50% of uh, this region, this line. Okay. And then the third zone of the distance relay that covers the remaining 50%. This is the remaining 50% of the line. Okay. So again, it covers this is your remaining 50%. So basically, uh, this region, this is the region for the zone 3, Z3 value. Okay. Now, as I have told you, in the case of the direction relay, which is also of two input relay, or the distance relay is also of two input relay. So we have to introduce the angle theta, which is known as a characteristic angle. So this is theta, this is the characteristic angle. So this characteristic angle as same as maximum torque angle in case of the directional relay we have discussed in other classes. So this is the phi L varies from 70 to 90 degree. Okay? 70 to 90 degree, as I have told you in case of the directional relay. phi L. So whenever fault occurs, the value of the phi L is very high. So the torque produced, that is Vi cos phi minus theta. So this theta we need to set up roughly around this value, 70 to 90%. So this we can set this characteristic angle like this. Okay, this is the theta characteristic angle. So we have the characteristic angle theta for each zone, that is same uh, for all the three zones. This one. Okay. So we have the theta and we have the phi L. Also, this is the phi L. Okay. Phi L, and other one is your theta. So this is all about the three zone setting of the distance relay. If I just consider the second relay R2, then the first zone of the second delay R2, that is 80% from the bus B, and one is the first zone of the relay R2, and the second zone is the time delay of R3, that is 300 to 600 millisecond. Okay, so to understand this, we have to draw the control circuit of the distance relay. Let us see how to draw the control circuit of the distance relay. Now, if I just draw the control circuit of the distance relay, then we have positive uh, terminal and we have the negative terminal here. This is the positive terminal and this is the negative. Okay. So this is the we have to draw the control circuit for this relay. Okay. So then we have the 1 unit, uh, that is the 1 unit of the directional relay. Let's say it is D1, and then we have the unit. Let's say it is uh, D2. Sorry, Z1. This is D1, and this is the Z1. Okay, and then we have the relay 86, which is the coil of the auxiliary relay uh, that is connected to the trip circuit of 52, that is the circuit breaker. Okay. So this is the trip circuit of 52. This is the 86. We have the hold on path also provided by this 86 relay, that is 86 1, and that is connected here, 86-1 here. And then we have from this point we have the unit connected, that is uh, known as this one as Z31. Okay, Z31, and then we have another unit that is known as Z21, that is somewhere here. Okay. Sorry, Z21 here. So this is your Z21, and then this Z21 is connected with one contact that is known as T, which is connected here. That is T1, and another contact that is connected here. This is T1. Another contact that is connected here. We have another timer contact. This is the timer contact, that is T1 and T2. So this is the control circuit of the distance field. So here you can see that T, that is the coil of the timer, 86 is the coil of auxiliary relay. We have three zones as I have told you: Z1, Z2, and Z3. So Z1, Z1, 1, Z2-1, Z3-1 are the contacts of zone 1, zone 2, zone 3, that is uh, Z1, Z2, and Z3. Two contacts of timers are there, that is T1 and T2 are the two contacts of timer, and T86 1-1, that is the contact of relay 86. D1 is the contact of the directional unit. Now sometimes we can utilize a different type of characteristic in case of the distance relay. We will see later on that what are the different types of the characteristics. So we have used the Moho type uh, uh, characteristics. We have the impedance type characteristics, and we have these are the different type of characteristics of the distance field. Okay, Moho type and impedance type. If I use Moho type, then this unit that is not required, because Moho type is inherently a directional. So if fault occur on reverse side, as I told you, then this relay does not operate. But if I use impedance relay, then it is not an inherently directional unit. So if I just draw the RX plane, just like the characteristics of the impedance relay, then it is just like this. This is the RX plane for the, the relay. So this line, this is the line to be protected. Okay, this is the line. So if I reverse, if any reverse part occurs somewhere here, it is inside the characteristics. So for that, I have to do uh, is the directional unit. So the contact of directional unit is as shown here. But if I use Moho, this is the contact of the directional relay. If I use the Moho relay, which is inherently directional, uh, like this here, then this contact is not required. So in case of fault occur, the posture of the relay, then Z1 operates, so this contact closes, and it gives negative, it gives energize the coil of the auxiliary relay 86, which is further energize the trip uh, circuit of the circuit breaker, and circuit breaker becomes open if fault occur in second zone. Okay, so we have discussed the step distance relay, that there are three different zones of distance relay, and the zone one, first zone is instantaneous in nature, whereas the second and the third zone are time delay zone with some value. So in this class, we have started our discussion with the distance relay, that how the distance relay works, what are the different type of the characteristics. Then we have discussed the step distance characteristics of the distance relay, and finally we have discussed the control circuit of the distance relay. So I'm going to stop here. In the next class, we will continue our discussion on the reach of the distance relay. Thank you.